Okay, maybe I'll just have to share this one so that we can have it. Okay. Yep. So that's great. Yeah. So the title is Design and Code. How to move from designing to code. And my name is Peter Ayeni. Yeah. So I'm really passionate about impacting and teaching technology and also social entrepreneurship. And one of the reason why I do this is because, yeah, I've also been have the opportunity to learn from amazing people, either for free. Like I started out in tech, not having so many resources, and a lot of the open source resources, mentoring, and stuff that I got give me the opportunity to be able to become what I am today. From a little town in Nigeria to learning and working with global companies around the world, and I've been able to get scholarship also. I've studied in some of the Ivy League school in the US and stuff, both in business and social entrepreneurship. So because of that, I like to teach all of this knowledge because I know it's not everyone that could have the opportunity to attend some of these schools or get some of this scholarship or stuff like that. So that's why, like, most of the things I know, I could give it back and support the community and other people who didn't have the opportunity to do that. So today we're talking about most of you here are you already a designer, so you're a design expert. So I'm not going to be dwelling on what you already know. You already know a lot about design. I was already also a designer myself, but I've not been designing for more than 5 years now. So my design will be like whack. You can see my slide is not really that good, but yeah, it's what it is. So you guys are expert designers, and so but we are going to transition to something else. Like we want to, and if you look at it, like design and engineering, like code and programming, it's always like the same thing. It's just like the implementation is different and the medium of communicating those solutions are different. Like designs with communicate solutions with visuals, and programmers communicate solutions with codes and stuff. So and both of them work hand in hand. You can have solutions on the web or on the apps or whatever solution we build without design, because that's the foundation of problem solving. But what exactly is coding in its first place? So what is coding? So there's some nice definition here. It said is the act of writing instructions for computers to perform specific tasks. So, and that's what coding is about. And it has evolved over the years, really, in different ways. There are a lot of people that talked about manually coding machine using some of these punch cards and stuff like that. I didn't make that kind of computers. So, but we know that there's kind of like encodings and tapes and stuff that people use in the past. But today we have for sophisticated machines, and then we have like programming languages that are like human readable languages that we could use to talk to computers. And why is this important? Because computers are machines. What they understand is just one and zero. So that's what computers understand. So how can we translate one and zero to something that computers can actually understand? So at the level of that, they have what we call machine languages. So machine languages write a little bit more complex encoding stuff, and then it's easier for people to write in a more easier way, and then machine can decode it and execute that functions. And after some time, we have what we call programming languages that are like higher level. So, and they need to have like a compiler. So compiler in this area means that like it's an interpreter for machines and humans. So we write these programming languages that looks like English language or any kind of language that we could understand. And then this compiler takes those language and instructions that we wrote and then translate it to one and zeros that computers can understand. And then that way, both humans and computers and machines can talk with the help of these compilers. So programming language are kind of codes. And then we have these compilers that all of these big companies, organizations maintain that have talks to different kind of machines. That's why you see that sometimes we have uh, some programs that run on Windows won't run on Mac. We have some programs that run on Linux won't run on this kind of machine, because all of these compilers for every machines and CPUs and stuff are different. So, and I wish one day we are able to have like similar interface across operating platforms, and we can talk one language and one compilers. But because people need to make money and stuff, we have not gotten to that level yet. But there's a way we could translate code from one machine to another. Like these days, we have Linux running inside Windows. So, and all of those things. So I don't want to go into so much technicalities, but if you have any questions, there will be a lot of time for that. And that's the essence of this session. So what I'm trying to say is that coding is like writing languages, instructions of what we want a computer to do. And then we get to the computer that takes the compiler, compile those languages we wrote, and translate to what the computer can understand. And the computer give us response and display it back to us. So everything we are doing right now, the voice over IP services we are using for videos and audios, and also for the web browser and everything, are all translation that the CPU is working on in microseconds and very, very fast. So, and all of these things is backed by computer science and stuff like that. But the thing is that these days you don't really have to be like a super genius computer scientist to code. That era is gone. Before, it was this elitist kind of space that we think like those people that code have to be this nerd and stuff. We'll talk about more about that. But computer scientists are the one that write some of this research, some of this compiler that we use. So it's their work. They research more into it. You understand? So that's why, like, sometimes I try to explain this to people, especially those that want to get into programming, and they were like, "Oh, I don't have to do all this expensive algorithm and all of these maths and all of these things. What does it mean?" You don't really have to. Even I don't work with expensive, crazy algorithms on my daily basis, because some of these algorithms have been written for years and years, and there are people that research on this work, and then when they get some of this research, then other people use it. And those are computer scientists. It's their job, it's what they do full time. They are they are researchers, like what we have with ChatGPT today. All of these things have been work of research even since the 60s. And then industry experts take it and then use it to solve business problem. And that's where we come in, that we call software engineering. So software engineering is about solving problems. So we take all of these solutions, big algorithms, machine learning, ChatGPT, whatever, libraries and stuff that's smart computer scientists did, and then we can turn them into things that people can use that can solve problems. So what we do is a software engineer is the approach of software development semantics. Application software engineer is a person who applies the principle of software engineering to design, develop, maintain, and test and evaluate computer software. So all of these things, writing code and stuff, they're like engineering. Like, and what engineering does is we take all of these principles and tools and ways, we put them together to be able to write software that is maintainable, that people can use, that can solve people's problem. So, and anyone can learn these engineering tools. So you don't have to be a computer scientist to be a software engineer, but being a computer scientist can aid you. But if you love problem solving, I believe you can be an amazing software engineer. And if you're an amazing designer already, definitely you will, because design is a core of engineering. Yeah, so and the next one is like we have design, we have code. So, and for most of you, you've understand like in coding, you have tools, you have a lot of things that we use. We have XD, we have Figma now that is all over the place. I use Figma, I love, I enjoy it. If you've been in design for long, you know Adobe, Photoshop, Macromedia, Photoshop, CorelDRAW, all of these tools that we use to solve problems and design graphics, UI, UX, product design, maybe 3D videos, and any kind of designs out there. And also for code, we have like mobile app development, we have front end development, we have back end development. So there are a lot of layers of things that in both of these things, and you see there is a lot of interlap between both of them. So maybe when we get to questions, we'll be able to like explain more on this interface, because I have worked in different aspects. I've worked in design, I've worked as a mobile app, I've developed mobile app, I've done front end and some back end also. So, and most of the time in all of this relationship, there is always in the typical engineering team, you have the designers that design, even before the designer, we have the UX, right, that do the research about the problem that needs to be solved. Why doesn't it need to be solved? Who are the target audience? What are all of these things? Even before we come to coding any line of code, we need to understand this, and then we have the wireframe, minimum wireframe for the research and stuff, and then we do quick prototyping to see that is this idea is even validated to be solved, and then the UI person come up with these amazing, brilliant ideas and all of the click through and stuff, and then we retest all of those things and make sure they are cool. And then when they are great, we're like, okay, do the handover to the designers, and then we design systems for them. We provide them with all of the colors, all of the tokens, all of the things that they need to do their job. We taught them we tell them all of the data that they need. They can use that to build the APIs. And then the front end will be able to take all of the designs and translate them into CSS, HTML, and JavaScript that we can use. You can see that there needs to be a synergy. And where this synergy came from is from the fact that, understanding what's achievable. Sometimes you could have this amazing UI that is really great, but then when you want to translate them to code, it's just really, really hard. You could have all this tug of war between designers and coder, and designer was like, why can't you do this? And the code like, yeah, this is amazing and beautiful, but it's just so hard and it takes some time, or it's so expensive to build. So, but by the time you understand like the code and the complexity behind it, I think it will even give you more leverage to be able to be a product designer or the product manager, to be able to manage these two amazing, talented people. Designers and code are amazing, talented people that are always at loggerhead at the place of requirement. So being that gap, it's really a fantastic place to be, and it can also accelerate your career, and you can get promotions from that and everything because you understand both languages. So, and getting to what we want to achieve today is it meant for me? Like, coding is something that it's really, really scary. I wanted to become a software engineer, but it took me like a long, long time. Like the first 10 years of my tech career, I was doing mostly computer engineering, repairs, networking, and A plus and everything. And I was the next 5 years, I was doing majorly design, UI, UX, branding, and graphic design and stuff. I do all of those. Yeah. So, but because, yeah, I know that I really love to code. And even for so many times, I was a web designer, right? I was using WordPress, any kind of no code tools. I was using them, and I felt like I know some few HTML and CSS and stuff. I could change some little things, but I don't really have the confidence to be able to like go into these things. Like, I'm like, what do I need? Do I need to be do I need software engineering courses? Do I need all of those things? And it's this doubt in us that we felt like maybe to be a coder, you just have to be this smart person. You have to be math genius and stuff. And you see all of this angle bracket and everything. It's really, really scary when you see them in, how huge they are. But what I want to do today is demystify all of these things. Like, if you see it long enough, it becomes familiar to you. And that is what I want you to take away from this section. So, because it's all about having this growth mindset. Like, yeah, it's scary, but it's because I'm seeing it for the first time, or because I'm not seeing it long enough. So when you see it long enough, you have to start to get familiar. If you go to a new country, for instance, like for instance, for me, I'm an immigrant to the UK. When I got here, everything was new, everything was strange. The driving was strange. I have a friend that told me that he was almost knocked down by a car because he doesn't understand that this was on the right side and this is on the left, like where he was coming from. So all of this changing, mail, all of those things is the same strangeness. But today, like everything is like looks normal to me. Like I think the first 3 months when I got to the UK, I was like a tourist every time. But today, like, it's so normal because I'm part of, like, I can't even feel like I used to feel like 5 years ago anymore. But for anyone that came to the UK for the first time, like, they have that similar experience. Everything will be new. Even for us, when you go abroad and you go to a new place, you feel like strange, you get lost easily and everything. When I went to Berlin for the first time, I actually got lost on the train. And then I paid an Uber driver who took me just like how many minutes to where I was going, and I had to pay. It's not even the taxi that I have to pay so much for, and that's what you pay for as a tourist, right? Because you're in an environment that you don't understand and everything looks strange to you. But what you just need to do is stick around a little bit longer. Just stick around, and you see that it's actually easy than it looks. So there's this quote I normally give to any group mentoring session, and I think it works a lot because especially in the area of like self-doubts, can I do this and that. So I love this movie Ratatouille, and every time I'm down or I'm trying to take on a new challenge, I like to see that movie. It's really amazing. So there's this guy Gustav that said this quote there. What I say is true. Anyone can cook, but only the fearless can be great. So, and I just have like paraphrased that quote and said, what I say is true. Anyone can code, but only the fearless can be great. So the thing is that you just need to stick around a little bit with code. You just need to try it. So, yeah, you can try the first time and everything looks like gibberish to you. It's okay. Drop it. Come back the next day. And then you see that it started to have meaning to you. And even these days, now that we have so many things that could help you. And I like to share my own journey also. Like, it wasn't as simple for me to get into tech or to start coding, even though that's what I've always and always loved to do. It took me so many times. Like I would jump from one programming language to another. I would start with Ruby. Today I will learn PHP. Today I would like, no, don't do PHP. Just go through and do this one. Then we get other opinion. Don't learn this framework. Go to .NET. Some people say, oh no, it's only C++ programmer that are the best. Like there's just so many opinions on that journey. You understand? Until I just like made up my mind. Like, okay, what I want to do, what do I want to develop on? And I start to critically pinpoint what I want and see that all of those noise. And then I was able to take charge of myself and I started building stuff. And that was when I started coding. And that's exactly what I'm going to do in the next section. I'm going to give you framework tools and everything you need to be able to start tomorrow and start write your own first line of code, and then you start to build on top of it. Yep. So, and this quote here, it's very, very important. It's more of like motivation. And because the reason why there is a lot of motivation in this conversation is because what you're trying to embark on is a mindset shift. And sometimes it can be really, really hard, especially when you're leaving your comfort zone. Maybe you have some amazing portfolio in designs, you have this amazing stuff you've been doing, and you're like, my God, I got this, I'm in charge of this. And then you're going to this new place that you feel like, oh, I'm a newcomer again, like, what is going on? And then you try it for 2 or 3 days, and like, let me just go back to doing my design. I know I know what I'm doing over there. So I think the idea is that you shouldn't be scared to be a beginner again. It's liberating. Trying to, I have two younger ones, like my kids, they're twins, and when I look at them, sometimes it's just like help me to relieve that childhood. But see how many times they have to practice things to be before they could be able to get it, and they don't even really get frustrated. They just try over and over again, and then the next day they still try the same thing. And look at how frustrating is it for them to be able to learn one thing. Like we have this singing learning platform that they teach them one thing over and over again. And the thing is that that's how we learn. If you look at ChatGPT, machine learning, whatever technology out there in AI, they also use this basic principle of how to teach a child: repetition, and that's it. So by repetition and trying again and try again, you'll see that you get better at this coding stuff. It's just about you trying. And I'm going to give you some of the tips that will actually help you to focus, and then to help you to try, and then help you to practice. So why this quote is this: Everything you see in computer science, software engineering, um, all of this ChatGPT and all of this Apple AI, whatever anyone is building, whatever you are going to build, is because of what everyone after us have built before. So we are all just building on top of that. You see, there is no uh, I won't say like, yeah, there are genius, there are amazing people that have moved this technology forward, which is great. But all of us are building on each other's geniuses. And that is the most important thing about software engineering. And it's a term we are going to hear a lot. Don't reinvent the wheel. So if a problem has been solved, there's no reason to solve it again. You understand? Like if you look at most of the foundational knowledge that ChatGPT, Bard, and all of them are using, it's the same research paper, it's the same research work. Everyone is just taking it into different direction, and that's how technology works. We have this same. If you look at Bitcoin, it's the same one paper, and everyone just took that code into different direction, and we have different kind of coin. So it's the same thing. So we are all sitting down on this giant of shoulders. The shoulders of the giant that come beyond us, and we can do great things because even Isaac Newton say that if I have seen further, it is by standing on the shoulders of giants. So, and that is what is going to happen in this career. Even for me in design, the amazing designers when I started that I have to stand on their shoulders. So I started like copying, like have their design on the side, and then I would try to replicate it. And then I would try again, I would see an effect, I'll try to replicate that effect, try to replicate this design. And then before I start to have my own flair, my own confidence, my own style, my own stuff. And if you've come to learn design or learn anything, you'll see that it's always that way. We start from copy other people. We start from looking at what other people are doing. We build on their skills, and then we start to gain our own confidence, and then we start to do our own originality. And it's the same thing that we are going to do in coding also. You can copy, you can look at other people, you can look at the source code, you can look at how they solve a problem, and then you can use that to learn and to become better. So on this session, we are going to talk about technology and tools. I want to run through all of these sections and we go to questions. So if you have any questions, just keep them in your notes, and then we will go through all of those questions, and then we can make this more interactive. So don't let me just like get out all of these informations to you, and you will love it. So technology and tools that we are going to be using for this. So, I promise we want to make things simple, straightforward, and easy for you us to get started with. When I started in tech in the beginning, I was learning Java, building desktop application. I learned VBA, then I learned like Oracle for database. I was learning MySQL. Like there were just so many things to learn at the same time. And before you know it, you're just like half-baked SQL, half-baked Java, half-baked this and that. And it was so really so hard to put all of those knowledge together. And we have it today also. So many programming language to learn. They will tell you there is new one, Rust is the one that is going to take over the world. They will tell you the machine learning that was going to change everything. But my own advice for anyone, especially if you are coming from design and you want to move into tech, easy, start with the web. The web is the universal language that everyone, every platform, everybody speaks. And it's so readily available and simple accessibility to it. So, and that's why, because if you're going to start with the web, it's so simple. You just need a web browser and then you can start coding for the web. That's how amazing the web is. And you just need three pieces of technology to build whatever we see on the web today, what we are doing right now. Everything, the video recording, whatever it is you've seen on the web, no matter how amazing it is, thanks to these three technologies that we're going to talk about: HTML, CSS, and JavaScript. So what is HTML? HTML is not a programming language. So you can see HTML as boxes and shapes in Figma. When you go to Figma tools, you see where we have shapes, and we have these fundamentals called shapes. HTML is like that. HTML is like fundamental called shapes of web, fundamental layout of the web. That's what HTML is. They are finite amounts of tags of HTML that you need to know. And it's the easiest to pick up because you could pick up an HTML and learn all of the syntax in, let's say, a weekend. It's Saturday and Sunday, you are an HTML expert. There are finite amount of tags that you need to learn. Even all those finite amount of tags you need to learn, you won't be using all of them in a project. Like you still use like select or handful of them and you'll be amazed what you're going to build. So HTML stands for Hypertext Markup Language. So it's the standard language used to create web pages. You can create a whole web page with HTML alone very well. It's all of the skeletal system structure of your web page, the text, the fonts, the images, and all of those things, the tag, navigation, layout, tabs, footer, header. You can structure all of those things on your web page using HTML. Then we get to a CSS. So CSS is like the properties on the right hand side, right? You know, on the top, you have this toolbar where you can pick all of those icons, all of those things in your Figma, and you lay them on the page. Then you need to change those properties, the colors, the shadows, the outlines, the blur, all of those properties on the right is what CSS gives to you. Even if you have been using Figma long enough, you see when you click on a particular element on Figma and you go to properties, on the right hand side, you see this CSS generated for you already. So just think about it in your head. Anytime you are adding colors, you are adding properties, you're adding something that change an element to behave in whatever way or to stand out in whatever way you're doing it. That's what CSS is doing for us. So you have been using CSS, you have even been writing CSS all your life. If you've been using Figma, is exactly what you're doing all of this time. So I don't need to go into this definition because of time. I want us to move quickly now. And the next piece is the JavaScript. So JavaScript is the only programming language here. Both CSS and JavaScript are not really programming languages. They're just like definitions of, I want my background to have red colors. I want my font to have white colors. They are definitions of what you want to see. So also CSS have a lot of ways to do stuff. So like, let's say in a week, you can pick up intermediate CSS and you start doing stuff. But JavaScript is actually where all of this, a lot of more things happen. Now you want animation on your website, you want to submit a form, you want to get interaction from people. All of this interactivity, upload, downloads, wait for a minute, talking to an API and get data, like the video we're talking about and all of these things. JavaScript gives us the programming advantage to be able to add interactivity, engagement, data modeling, so that the website we are saying is not just static HTML and information, it can be dynamic and interactive, like a Facebook, like a Twitter, and ADP list website. JavaScript gives us the advantage to be able to do that. And I say, like in 2 months, you can pick up the basic JavaScript you need to start in adding interactions to any website. So bringing all of this together to build a website tomorrow, HTML and CSS, you can build any website. And I will say you should start from there. HTML is used to create the structure and content of the web page, like the headers, the paragraphs, and the images. All of these layout blocks that we create. CSS is used to control the appearance of the HTML elements on page, such as colors, layouts, and fonts. CSS